Welcome, everyone. Today, we are exploring a critical paradigm shift in cybersecurity, unified exposure management. As frontier AI models automate vulnerability discovery at machine speed, our traditional defenses are failing. Let's get started on how we harden the enterprise. Let's begin by defining our core concept. What exactly is unified exposure management, or at its heart? is a holistic architecture that aggregates and normalizes vulnerability data from across your entire enterprise. The basics involve tearing down the silos between your application security, cloud security, and infrastructure tools, consolidating them into a single exposure data lake. Why is this suddenly a board-level priority? Because of the AI era. Frontier AI models, like Anthropic's Mythos, have automated vulnerability discovery. They can uncover 0 days in minutes. This creates a vulnerability deluge that traditional, human-speed triage simply cannot handle. How do we survive? By using platforms to ingest this massive telemetry and apply defensive AI to filter the noise. In our deep dive, we see that modern enterprises use to process hundreds of billions of findings, shrinking their mean time to response to single-digit minutes. We must fight machine-speed attacks with machine-speed defense. Take a look at this flowchart, which maps the transformation from legacy security to At the top, we have fragmented scanners, your SSD, DSD, and cloud tools producing overwhelming noise. This data flows into the Unified Exposure Management Platform, which ingests and normalizes it into a central exposure data lake. From there, AI analysis converts the raw data into prioritized risk intelligence. Ultimately, this enables machine-speed remediation at the bottom, replacing manual bottlenecks with automated workflows. To understand the necessity of we must understand the threat, the AI vulnerability deluge. What is this? It's the exponential explosion of software flaws discovered by advanced AI. The basics are terrifying. Frontier models can read massive codebases and act as zero-day factories, finding logic flaws that human auditors have missed for decades. Why does this change our defense strategy? Because threat actors are leveraging these models to compress the attack lifecycle. Reconnaissance and exploitation now occur in near real time. How are they doing it? The AI doesn't just find one big bug, it chains multiple low-severity vulnerabilities into a devastating critical exploit path. In our deep dive, we recognize that the window between a patch being released and an exploit being weaponized has collapsed. If your organization relies on routine 30-day patching cycles, you are operating on a legacy timeline. You are exposed. This timeline illustrates the compressed AI attack cycle. The AI model scans the codebase and identifies seemingly minor flaws. Crucially, it then chains these vulnerabilities together to generate a critical exploit path in minutes. The pivotal moment is the intervention node. If your platform triggers automated patching fast enough, you secure the system. If you rely on slow, manual triage, the path leads inevitably to system compromise. With thousands of vulnerabilities discovered daily, how do we prioritize? We use contextual risk scoring, often powered by a risk intelligence graph. What is this? It's the evaluation of a flaw based on its real-world business context, moving beyond flat CVSS scores. The basics are highly practical. A critical 0-day sitting on an air-gapped test server is not the same emergency as that exact same 0-day on your public-facing payment gateway. Why is this distinction vital? Because AI scanners produce an unmanageable volume of findings. We must filter out the noise. How does do this? It builds a risk intelligence graph, dynamically correlating the raw vulnerability with asset criticality, data classification, and live threat intelligence. In our deep dive, we see that the platform can even downgrade a risk score automatically if it detects that a compensating control, like a WF, is actively blocking the attack path. Context is everything. Let's map out the risk intelligence graph logic. On the left, a raw vulnerability with a severe 9.8 CVSS score enters the graph. It is combined with the asset context public-facing PI and threat intel showing it is actively exploited. The graph accurately outputs a critical true risk score. However, look at the bottom path. That same 9.8 vulnerability, when combined with an internal sandbox asset context, is downgraded by the graph to a low risk score. This intelligent filtering saves your security team countless hours. Once we have prioritized the risk, how do we communicate it effectively? Through persona-aware intelligence. What does this mean? It means delivering tailored security insights adapted to the specific role of the user interacting with the platform. The basics are intuitive. Your CISO, your security engineers, and your software developers all require entirely different perspectives on the exact same vulnerability data. Why must we do this? Because throwing raw JSON logs at a CISO or high-level risk charts at a developer creates massive friction and slows down patching. How do modern platforms solve this? They deploy specialized AI agents to translate the risk intelligence graph dynamically. As a deep dive, when a massive zero-day hits, the generates a board-ready exposure summary for the CISO. Simultaneously, it maps the exploit chains for the security engineer and pushes actionable, line-by-line code fixes directly to the developer's IDE. One dataset, perfectly customized for every persona. This flowchart visualizes persona-aware intelligence. The vast data lake feeds into the persona-aware AI agent at the center. The agent acts as a universal translator. It branches into three distinct views. The strategic view provides the CISO with board-ready metrics. The tactical view gives the security engineer deep exploit path analysis. The operational view delivers actionable code fixes directly to the developer. Everyone gets exactly what they need to act immediately. Now we reach the execution phase, automated remediation orchestration. What is this? It's the complete automation of vulnerability routing, ticketing, and service level agreement, SLA, tracking. The basics remind us that finding a bug is only half the battle. Coordinating the fix across dozens of distributed development pods is where organizations fail. Why is orchestration mandatory now? Because when AI scanners double or triple your vulnerability volume, manual ticket creation and email chasing will break your security team. How does orchestrate this? It leverages a no-code workflow engine to push prioritized findings directly into the developer's native tools, like Jira, ServiceNow, or Slack, complete with the context they need. For our deep dive, consider SLA enforcement. If a critical vulnerability is ignored and breaches its 24-hour patching SLA, the platform automatically triggers an escalation policy, notifying leadership and blocking the deployment pipeline until the fix is merged. Let's walk through the orchestration process flow. A verified critical risk hits the workflow engine. It instantly auto-creates a Jira ticket equipped with all necessary developer context and starts the SLA timer. If the developer applies the fix in time, the system auto-closes and verifies the ticket. But if the SLA is breached, it triggers the red node, automated escalation and CI/CD block, ensuring vulnerable code never reaches production. To fix vulnerabilities efficiently, developers need code context and root cause understanding. What does this mean? It means tracing a vulnerability back to its exact origin within your complex software supply chain. Look at the sample pseudocode rule on the slide. If the vulnerable library is log4j and the asset is public, instantly trigger a tier 1 response. Why is this deep mapping necessary? Because AI adversaries target deep, nested dependencies. Defenders must understand the provenance of every line of code. How do we achieve this? Platforms utilize AI code insights to map every open-source dependency across the entire enterprise architecture. In our deep dive, imagine a single zero-day drops for a popular open-source package. That package might be used in 50 different internal microservices. Instead of logging 50 separate confusing alerts, the traces them to the single root cause and pushes a unified, targeted update to all 50 repositories simultaneously. This sequence diagram shows root cause resolution in action. A zero-day is disclosed in an open-source library. The exposure platform ingests this and uses AI to trace the entire enterprise dependency graph. It discovers that microservice A and microservice B both use the library. The immediately pushes automated pull requests to both repositories, fixing the root cause globally and instantly, rather than waiting for individual teams to discover the flaw. Let's apply these concepts to a real-time, highly critical use case, defending against the zero-day factory. Imagine an AI threat actor uses a frontier model to discover a temporal trust gap, a microscopic race condition in your enterprise's legacy middleware. The attack commences at machine speed, chaining this gap with an authorization flaw to exfiltrate data. Now, the defense activates. The platform ingests the anomalous telemetry from your XDR sensors. It instantly queries the risk intelligence graph, which realizes this middleware connects to a sensitive customer PI database, elevating the risk to critical. The orchestration engine fires immediately. It sends an automated isolation command to your API gateway, cutting the attacker off in microseconds. Simultaneously, it pushes an AI-generated hotfix directly to the responsible development team. the attack is contained and the root cause is patched. This is what true machine versus machine defense looks like in production. Let's trace this real-time defense scenario. The AI attacker exploits the middleware and the telemetry is instantly sent to the The risk intelligence graph processes the data, maps the asset to a PI database, and assigns a critical score. This triggers the orchestration engine, which executes two parallel actions: microsecond API isolation to stop the bleeding, and sending an AI-generated hotfix to the developers to cure the underlying disease. To conclude, as we harden our enterprises, we must look to the future, governing the AI agents themselves. What does this mean? Must evolve to manage the identities and permissions of the autonomous AI agents we deploy. The basics are clear. As we give AI agents the power to write code and remediate bugs, these machine identities become a massive new attack surface. Why is this critical? Because if a highly privileged defensive AI agent is compromised, it could be weaponized to introduce stealthy backdoors instead of fixing them. How do we prevent this? By integrating our platforms deeply with zero-trust identity architectures, strictly scoping agent permissions, and constantly monitoring for unauthorized shadow AI servers. The era of manual, reactive security is over. You must embrace continuous, unified exposure management. To master these cutting-edge AI security architectures and future-proof your career, I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final mind map summarizes the pillars of unified exposure management. A robust strategy relies on a consolidated data lake to ingest all telemetry. This feeds the risk intelligence graph to apply business context. The prioritized risks flow into automated orchestration for rapid SLA enforcement. Finally, spanning all of this is AI agent governance, ensuring strict zero-trust identity controls over the very AI tools securing your enterprise.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks, like you are watching currently Mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available, like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.